Okay, we're going to be talking today about parabolas. Now, I know we've talked about parabolas all year. We know what they look like, we know how to complete the square, we know how to graph them, but now we're going to talk about them in a little different way. So, for instance, if you look at the chart that we have here, we have really two types of parabolas. Now, the types that we're used to seeing look like this one here. It's an x squared type, so just kind of a rough sketch next to it, it would look something like this. We've seen that a lot. Now what we're going to start talking about is things that are y squareds, okay? So for the first one, y squared has a positive 4ax. I'll go through what all that stands for. But if it's positive, just to get an idea, it would be pointing to the right, okay? A y squared with a negative 4ax, like the next one, would be pointing to the left. Now, we'll also talk about the fact that these guys are not actually functions, because if you did a vertical line test on these y squareds, they're not functions, but we can still work with them. We can still find things out about them. Okay? So what I want to talk about today mostly is just kind of the graph of them, a little bit of vocabulary, and then we'll do a few problems, and then we'll talk a lot more in class tomorrow about what all this means. Okay, right now, we're going to have everything, all the parabolas are going to have vertex at 0, 0. We'll talk about the shifting and how that works later on, but just for now, till we get the hang of it, we're talking about vertex at 0, 0. So if I were looking at this very first one, let me try to kind of sketch in here what's happening. Y-axis, x-axis, vertex right here at 0, 0. So if I were to go down this little column under vertex, for every single one of these, you could write in 0, 0. All the way down. And I know you can't see the last one on my screen, but you've got it there. Okay, now, something called a focus. This is new for us. A focus, it's a point. And it's a point on what we call, let me put it right in here, the axis inside the parabola, so it's a focal point. And I'll talk about what that does for us tomorrow. All right, as well as, here's a new word for you, directrix. It's always a line. So if the parabola is pointing to the right, the directrix is going to be to the left. And the distance between, I'll say this a couple times, distance between vertex and focus, vertex and directrix should be the same distance. All right, and we'll talk again about what that happens tomorrow. Okay, so if I'm talking about the focus, I'm going to talk about it as a point. It's going to be for this parabola here, the point A, 0. Okay, the directrix will be the line, x equals negative A. It's a vertical line. The focal diameter, okay, think about the diameter of a circle. It's all the way across the circle. So the focal diameter is a line segment that goes through the focus all the way across the parabola. So that green thing I just sketched in would be the focal diameter. And its distance is 4a. Okay, we'll do an example in just a minute. Don't worry too much. All right, then if we take a look at the y squared negative right below it here, and I start doing the same kind of thing, I'm going to put the y-axis here, x-axis to the middle, because again, all of these will have vertex at 0, 0. Then I'm going to put my points on there. Okay. There would be my focus. My directrix would be in the opposite direction. So for focus on this one, I'd say the focus then is going to be negative a, 0. The directrix is on the positive x-axis, x equals positive a. The focal diameter, 4a. Okay, so I'm just filling in the chart here. All right, let's move up to our x squareds now. X squareds are kind of the ones that we're used to seeing here. All right, here we go. X squared, let's just do one of them. I think you can probably figure out the other one from there. X squareds this time, pointing up, vertex at 0, 0. Focus will be up this way. Directrix will be going in the horizontal direction. So if I asked you where the focus is, we'd say instead of A0, we're going to say 0A. The directrix will be a horizontal line, y equals negative a. The focal diameter, still positive number, 4a. All right, I can have you guys fill in that bottom one there. Okay, so we just filled in the chart. Let's just see how all this looks in an actual problem. So if you look at number 1, y squared equals 12x. First thing I want to point out, you have to make sure whatever's being squared, the x squared, the y squared, whatever it is all by itself on the left-hand side, and everything else is on the right. So if you look at these 4 problems here, 1, 2, 3, 4, all of them are in the right form. Later on, we'll have some that aren't there yet, but all of these are good. So let's just start kind of looking at this from the way I'm going to ask it on a quiz or test. I'll say list the vertex. Okay, it's y squared. It's going to be at 0, 0. Okay, so even if we don't know exactly what's happening, we know it's going to be here, starting here. This one should be pointing to the right. Okay. Now, this number in front of x, this 12, that's our 4a value. All right. So if 4a is 12, a must be 3. So that's going to be the amount I go from the vertex to the right and left for this parabola. So if I go a equals 3 to the right, 1, 2, 3, that would be the point where I put my focus point. And if I go 3 to the left, that vertical line would be my directrix. Okay, so I don't know if you can kind of picture it already. Parabola pointing to the right through 0, 0. Now there's another term I need. I need the focal diameter that we just talked about. Now the focal diameter is 4a. It's the entire value. So for us it's 12. So what that means is from the focus, this red focus here, I need to go 12 all the way top to bottom, which means 6 in each direction. Okay, so 6 up. There's a point, 6 down. Okay, you'll have graph paper on the quizzes and tests. Now I can kind of sketch this parabola, and it's pretty wide. Okay, all right, we'll try number 2 as well. We'll talk through it, and then I'll have you guys try 3 and 4 on your own. So make sure you complete 3 and 4. They're x squareds. We're going to do number 2. It's another y squared because it's kind of new for us. All right, again, vertex at 0, 0. Not going to change it just yet. We'll get the hang of these first. 4a would be negative 8. Actually, you know what? Let's just call it 8 so we can talk about it as a distance, and I'll talk about that in class. So a is 2. Okay, so if I'm graphing this one, it's another y squared, vertex at 0, 0. This time I'm going to go 2 to the left for the focus, 2 to the right for the directrix, and then this focal diameter all the way across the focus should equal 8. So a positive 8. Diameter, we always give a positive number. So if this guy here is my focus, and it should be 8 across from that point, 4 up and 4 down. So 4 up from the focus, 4 down from the focus. This one's pointing left because it's a y squared negative value. All right, so you guys try 3 and 4. They're x squareds, but the idea is the same. Okay, the last 2 problems we're going to do here involve giving me the equation of a parabola having been given some information. Now, some of you are pretty good. You'll be able to do these without sketching a graph. I'm going to go ahead and sketch the graph so we can start visualizing it together. So if I look at number 9 here, it says the focus is at 0, 2. So it's got to be this distance. There's my focus. And the vertex is at 0, 0. So one thing you want to start saying to yourself is, which way should this open? So if the vertex is here at 0, 0, focus is in the up direction, this one must be opening up. Okay? So if I'm asking for an equation, it means the x squared is on the left, the y is going to be on the right. Now, what our job here is to figure out what's our 4a value, because that's the value that's going to go right here in front of the y. And the way we do that is, from vertex to focus is our a value. So if a is 2 for this problem, 4a must be 8. So the answer would be an 8 in there. So the answer to this problem is x squared equals 8y. All right, let's do one more of those where we're kind of going backwards. Look at number 10 here. Directrix is a line, x equals negative a half. So x equals negative a half, vertical line. Okay, vertex at 0, 0 again, that's nice. So if the directrix is to the left, this one must be pointing right. So now when I start my equation for this one, I'm going to be saying something like y squared, because it's pointing right, equals positive something x. And I've got to figure out what goes in front of that x. So the distance from vertex to directrix is also my a value. So a is a half, which means 4a must be 2. So in the final answer, I'm going to put a 2 in front of that x. So y squared equals 2x would be the final answer.